Hi, welcome to part 2 of my solution to this 13-mark examination question. In part 1, which you can see among my videos, it's entitled 13-mark question part 1. We looked at solving the sections A and B, where the emphasis was on how to complete the square for any quadratic expression, and also using our completed square to work out what our maximum value and where it occurs as far as the x coordinate of that maximum point, and we were able to find that successfully. So with this question now, we're going to focus on another aspect. In this case, we've been given an extra graph. In this case, it's a straight line, and we've been told that they intersect at 2 points. Now, what you should note is when two graphs intersect, in this case we have y equals 7, add the 4x minus 2x squared, and we have y equals 4 minus x. Now, when they intersect, it means that there are 2 points in this case because of the shape of the quadratic curve, where the linear graph, the 4 minus x, will intersect. To find that point, we want to look at the position where they are both equal. Because both equations have been written in the form y equals, that means that we can safely rewrite them as 4 minus x should be equal to 7 add 4x minus 2x squared, because after all they are equal. So now we can see a quadratic emerging here, so we want to rearrange again so that we can achieve ax squared plus bx plus c, our almighty formula. Now, because I want to minimize the appearance of negative terms in my equation, I will be adding 2x squared to both sides, and what else? Subtract 4x from both sides, and then I will subtract the 7 from both sides. So once all that is done, my left hand side is going to look like this. So I have 2x squared, then I have my minus x minus 4x will give me minus 5x, and then I have 4 take away 7 gives me negative 3, and all of the right hand side would have been reduced to 0. So now I need to factorize this equation. So I'm looking for two numbers, alpha, beta, so that the product will be 2 times negative 3. So I'm looking for the product being negative 6, but then their sum will be minus 5. So with a little think, you will be coming up with a 6 and a 1, and since we want to add them to get a bigger minus 5, so we would assign the negative to the 6. Okay, so we have now 2x squared minus 6x, add 1, x minus 3 equal to 0. Okay, let's try and factorize that. So if I put my curtain down here, I would have 2x as a common factor on the left hand side, with x minus 3 in the bracket. Now whatever I get in the bracket here will be the same thing I get here, so you can actually just repeat that and figure out what should go out to make the value a plus 1 when you multiply, and that should be what. Yeah. Okay, now x minus 3 here is a common factor, leaving us with 2x add 1 for our second bracket. So again, we do what we do best. We have two numbers multiplying to give us a 0, so that means that either x minus 3 is 0 or 2x add 1 is 0. Now if x minus 3 is 0, meaning x should be 3, and in this case 2x should be equal to negative 1, and therefore x will be minus a half. So now we have the x coordinate of the point where the two graphs intersect. We now need to find the corresponding y value at that point. So we say y will be, I will be using the linear function because that's easier. You could also use a quadratic, it doesn't matter, you should arrive at the same answer. So in place of x, I will be substituting 3. So I have 4 minus 3, and that gives me 1. And what about the other side? I have x to be minus half, so my y will be 4 minus half. That gives you 4 and a half, that gives you 9 over 2. So remember, the question is asking for just the x coordinate, so you could actually finish off the question here. Okay, but sometimes you would have questions that would tell you or ask you to find the coordinate of the point where they meet, in which case you would add on this extra bit. Okay, so please note, I just decided to add that just to give you a complete overview of how far it could go, but as far as part C is concerned, you only need the x values. Okay, now let's proceed to part D. In part D, we've been told that the finite region bound by the curve and the line is rotated. Now if you can visualize that, if we have the curve being rotated about the x-axis, then a solid shape will be created. Okay, now as a result, whatever calculations we do next would require that we work out the volume. Okay.